Welcome to my data analysis presentation. First, I'm going to go over the methodology. We'll be looking at my code and how I went about creating it and some of the challenges I had throughout the coding process. This is my code. I don't have time for a full breakdown, but I'm just going to hit the key points of the coding portion of my project. First, I scraped the data from the CO2 emissions website. Then I stored it in an unclean CSV file, which is this one right here. It's messy because it has commas and non-straight numerical data. Then I stored my data in an SQLite database, made some tables, inserted the data, and cleaned it up using some simple commands. Then after that, I converted the clean database into a new CSV file, which is this one. It's cleaner than the original. Then I set up for my statistical analysis of my data. It came out like this. It's basically just the most important stuff I thought to pull from my table. Then I visualized it using 5 different plots. This was probably the hardest part of my code since it was hard to get a concise and readable plot for each one. Now we're going to go over my results and insights of the data. I know this is a lot on this page, so I condensed it down. Global CO2 emissions have reached 38.5 billion metric tons, with China, the US, and India as the top contributors. Emissions are still growing despite renewable energy efforts, and the massive gap between countries from just 2,000 to 12 billion metric tons highlights global inequality in emissions. High total emissions don't always mean high per person emissions. For example, the US emits more per person than China. The wide emissions range shows major disparities, meaning a few countries drive most emissions, and tackling climate change will require customized, not one-size-fits-all global solutions. Now we're going to go into my visualization of the data. This graph shows a steady rise in global emissions since the year 1950. I find the drop in 2020 interesting, as it shows how big of an impact COVID-19 had on us. On the left is a bar graph of the top CO2 emitting countries, and on the right is a bar graph of the highest CO2 emitting countries per capita. I think it's notable that a majority of the top 10 in the left graph are not on the right graph. This is due to high population differences. Here we see a clear positive correlation between population and CO2 emissions. Larger populations tend to emit more. Notably, even after removing outliers, the trend stays strong, and the heat map shows a correlation coefficient of 0.809, confirming the relationship. This pie chart highlights that just 10 countries are responsible for 68.8% of global CO2 emissions, with China alone producing 32.9%. To match China's emissions, you'd need the combined output of 185 other countries plus Saudi Arabia. It shows a stark imbalance where a few industrialized nations dominate the world's carbon footprint. Lastly, I wanted to thank you for watching. See ya.